I'm about to get real mad. That's what's up. Had a kid come by today. I think we're good.
That's why he's mad he had a kid come by today.
All right, watch your language, everybody, because this is our inaugural episode of doing YouTube live. So everything you say is being beamed out to the internet right now. Say hi to our subscribers.
Hola.
Hey guys, smash that like button. Hit the notification bell. It really helps me out so I can keep making great content. So the last thing we're going to learn in this class is proper etiquette in the YouTube comments section. And then also, we're going to talk about quadratics. So, what's a quadratic? Without using any profanity, what is a quadratic? What's it look like?
Well, quad 4.
No. It's fine if you don't remember. It just means you've been ignoring me for the last 3 months. That's fine. Doesn't even hurt my feelings anymore. A quadratic is something that has x squared. That's an example of the most basic of quadratics. Now, eventually, before it's all said and done, we're going to graph quadratics. When you graph them, they make a shape that looks kind of like that, called a parabola. Okay, so that's a quadratic. It's got x squared in it, and it looks like a parabola. We're going to finish up this class by graphing quadratics. So I don't want you to worry about the parabola or the graphing quite yet. Today we're going to work on solving them. Solving them is one of the steps you have to do in order to graph it. I'll explain that a little bit later, how solving them helps you graph it. But for now, we got to learn how to solve them. And I'm going to teach you a few different ways to solve quadratics. I'm going to teach you right now using something called the square root property and completing the square, as you can see from the title. And then I'm going to teach you how to solve it using something called the quadratic formula. So let's start off with a very basic, simple quadratic. X squared equals 32. So when you have a problem like this where it's just x squared all by itself on one side of the equals, what procedure do I do in order to isolate the x, in order to get x by itself? I square root both sides. Exactly right. When you do that, this is called, because mathematicians are so creative about naming things, the square root property. Square rooting something is answering the question, what thing multiplied by itself gives me 32? So here's what the math looks like. The square root of x squared equals the square root of 32. I take the square root of both sides. So the left side's really easy. The square root of x squared is x. Here's the part that's a little tricky. What's the square root of 32? Very good. 4 square root of 2. So what we're saying here is 4 square root of 2 multiplied by 4 square root of 2 should equal 32. Is that the only answer? If I'm asking you, that means no.
No.
No, it's not. If I said, what's the square root of 25, you would say 5, right? 5 times 5 is 25. Is that the only number you can multiply by itself to get 25? Could I? To get 25? I don't think so. I'm just talking about 25. 5 times 5 is 25. Is there another number multiplied by itself that's also 25?
No.
Yes.
It's a rational number.
Nope, just a regular old number.
Where?
What number times itself is 25 besides 5? There is one. It's just a regular number. 1 times 1? That's not the same number. Same number. Five times 5 is 25. And so is negative 5 times negative 5.
Oh my goodness.
This is a valuable lesson for you to learn. When you take the square root of something, you get 2 answers. One of our answers was 4 square root of 2, and the other answer is negative 4 square root of 2. We have 2 answers, and this is one of the characteristics of a quadratic. Each one of these that you solve is going to have 2 answers. 2 answers to your quadratics. Okay? So, what do you do if you've got one that's not set up quite as nicely? For example, I can still use the square root property here if I want. I'm just going to have to do a little work. In the last one, when I used the square root property, x squared was all by itself. I can do that here if I get the x squared by itself. So how do I do that? Okay, let's add 50 to both sides. That is a good plan, and I support it. So that gives us 5x squared over on the left side, and 0 plus 50 is 50. Okay. I would go ahead and divide by 5. That seems like a great idea. You are so smart. I can tell your math teacher is very handsome. X squared equals 10. Now I can do the square root property. I got x squared all by itself. Let's take the square root of both sides. So I'm going to have the square root of x squared equals the square root of 10. So the square root of x squared is x. Square root of 10? Just square root of 10. That one can't be simplified. There's no perfect square sitting in there. And negative square root of 10. Very good. 2 answers every time. There they are. Positive square root of 10 and negative square root of 10. Hey, that seems pretty easy. Yeah? You think that it's easy, but also you know what's coming. Here's an important problem for you to know how to do. That one's really important because, as I told you, we're going to learn how to solve these by completing the square. I haven't told you what completing the square even means yet, but what I will tell you is part of the process of solving these by completing the square ends up looking like this, where you've got a set of parentheses squared. Believe it or not, I can take the square root of that right now. The left side is all squared. The entire left side of this equation is squared. So I'm ready right now to square the entire left side and the entire right side. I can do it right now because the left side was completely squared. There was nothing on the left side that wasn't squared. Okay? Over on the left, when you take the square root of something squared, what happens? Yeah, it's just x plus 1. The square root and the squared are gone. Come on, just say that loud. Confidence. Come on. Confidence! What's the square root of 12? Very good. You are very good at simplifying these radicals. 2 square root of 3, right? or
Wait, what's it?
negative 2 square root of 3. So one of the ways that you can write this, that this is both positive and negative, is to put a plus minus right there to show it's the exact same thing, only one time the 2 is positive and one time the 2 is negative. There's nothing wrong with also just writing it twice. You could do x plus 1 equals 2 root 3, and then you could do x plus 1 equals negative 2 root 3. But I'm going to encourage you to do it this way because the quadratic formula, which is another thing we're going to learn tonight, looks like this. It's got a plus minus just like that. So we're going to try to get used to this as we're going through these problems. Cool. Do I know what x is yet? I do not. What do I have to do? I got to subtract 1 on both sides. Good. So over on the left side, x plus 1 minus 1 is x. On the right, I cannot combine the negative 1 and the 2 because the 2 has that growth on it, the square root of 3. So I got to leave those separate. So it's a negative 1 and then plus minus 2 square root 3. Now by writing it this way, I've saved myself a little bit of trouble. I have written both what it looks like with a positive and what it looks like with a negative in one answer. Well, that one really wasn't too bad because, yeah, I had a thing in parentheses squared, which was a little rough, but the thing that was in parentheses squared was pretty simple. X plus 1 is not that big of a deal. Let's talk about what to do if the thing in parentheses is a big deal. 5x minus 2 squared equals, and let's really ruin your life, negative 9. So this problem's a big deal for a bunch of reasons. Number one, the thing in parentheses is way grosser than just x plus 1 like on the last one. And number two, it equals a negative, for God's sake. What is happening? But the good news is I can use the square root property here because the left side of this equation is all squared. The entire thing is squared. So I'm ready right now to square root both sides. There we go. What will it look like on the left side after I square root 5x minus 2 squared? Yeah, the squared and the square root just cancel out, and I'm left with 5x minus 2. Cool. What about on the right side?
I say we just leave it.
What's the square root of negative 9? He asked to a class that learned about complex/imaginary numbers a week ago.
Do square root of negative 1 times square root of 9.
Uh-huh.
You get square root with imaginary and the 9.
Uh-huh. What's the square root of 9 then? So it's 3 times the square root of negative 1.
I.
And the square root of negative 1 is I. So it's
3i.
3i.
Add 2.
Is it negative 3?
Yeah, positive and negative 3i. When you take the square root, you got both. Now what would you like to do? Now we can add 2. Now I like it. So over here we get 5x, and we cannot combine the 2 and the I. Those aren't like terms, so we'll just do 2 plus or minus 3i. Divide by 5. Okay, so I'm going to show you 2 different ways you can write this answer. First, I'm going to show you the easy, sort of lazy way. The lazy way to write this is 2 plus or minus 3i over 5. That's a lazy way to write it, and I like the lazy way. You could also write it, if you wanted to, here's your alternate way to write it, 2 over 5 plus or minus 3I over 5. In other words, you could divide each individual piece by 5. Both of those are acceptable. Or if you really wanted to be a maniac, and you don't, but if you really wanted to be a maniac, 2I over 5 plus 3I over 5 and 2 over 5 minus 3I over 5. Instead of doing the plus minus symbol in the middle, you could write it out twice. Now, that's how a psychopath would do it, because that's way more writing than I feel like doing, but it's correct. I want you to understand that when we put the plus minus sign in there, that is 2 answers. I know we're only writing one thing, but because it's got a plus minus, that's 2 answers. That's going to be relevant to us in the future, that it's 2 answers every time.
Now on the homework,
Mm-hmm.
the second way you wrote it,
Mm-hmm.
the 2 over 5 plus or minus 3I over 5, that's the way it was looking for it. Because there was
Mm-hmm.
a couple times I wrote it the first way and it counted it wrong because I
Mm-hmm.
didn't split it apart.
Mm-hmm. Yeah, they're both acceptable. You just got to do the
homework
form that it's asking for.
Yeah, the homework
Yeah.
will take the first one.
Yeah, you got to be careful about the form that it's asking for. That matters. If it says like A plus BI form, that's this one. Got to be careful. Got to be good, for goodness sake. Now, these 2 problems here, this one and this one, are the most important ones leading up to learning how to complete the square. Because when you complete the square, your problems end up looking like this, okay? Let me show you. So the idea of solving these problems by completing the square works like this. I really want to use the square root property on this problem. The square root property was easy. I liked it. I want to do that again. Problem is, I can't. I can't use the square root property on this. Why not? It is. Look, p squared.
Well, like the
But
whole
the
thing.
thing's not together.
Yeah, the whole thing isn't squared. Could I just make this squared? Is there a way that is there some like math voodoo I could do to make it squared? And the answer is kinda. Now I'm going to show you how to do this one. And let's see if you can tell me why this works. Can you tell me why a simple plus 1 solves all my problems?
A squared plus b, something like that?
Uh-huh, you're close. I wanted the left side to look like something squared. How is plus 1 going to do that for me? Is it possible that I could, and I'm just spitballing here, factor the left side?
That's the word I was
The word you were looking for is factor?
I don't know. Spitball.
When your mouth starts making that sound, I do not think factor is the thing you're about to say. But yes, factor is the correct answer. I can factor p squared plus 2p plus 1. What would it look like when I factored it? What are 2 numbers that will multiply for 1 but add for 2? 1 and 1. And isn't p plus 1 times p plus 1 really the same thing as p plus 1 squared? We did it! The left side is squared. And the right side's 4?
Yes.
No!
You have to add 1.
I have to add 1. I added 1 to this problem so that I could make this a perfect square. That's why it's called completing the square. P squared plus 2p was not a perfect square. P squared plus 2p plus 1 was. I could factor it into a perfect square. But the only way I could do that is because I put a plus 1 there. I can't put plus 1 in a problem just because it makes it easier. If I put it on the left side, I got to also put it on the right side. And 4 plus 1 is, let's see, divide by 3, carry the 2, 5. 4 plus 1 is 5. And now we're set up to solve this problem using the square root property. Let's do that. So I'm going to square root both sides. What's the square root of p plus 1 squared? It's p plus 1 equals the square root of 5 equals the square root of 5. Positive and negative. There you go. Positive and negative 5. Now what?
Solve for P, right?
Yep.
Subtract 1.
Yep. Subtract 1 on both sides. And I get p equals negative 1 plus or minus the square root of 5. Shazam! So let's ask the obvious question. I just told you on that one, plus 1 was the key to success. I am 99% sure I am not going to be doing that for you on, let's say, a test, telling you what needs to be added to both sides. So how did I know it was 1? Of all the things we could have added, why plus 1? How did we know that plus 1 was going to make this a perfect square? How did I know plus 2 wasn't going to work and it had to be plus 1? So let me give you a similar problem. And I can tell you right now, with b squared plus 4b, adding 1 to both sides is not going to cut it. B squared plus 4b plus 1 is not a perfect square. It's got to be b squared plus 4b plus something. I'm going to leave a little space there for something. How do I know what the something should be?
You
Cut
cut the middle number in half.
the middle number in half. So I take the middle number, which is 4, divide it by 2. That gives me 2. But b squared plus 4b plus 2 is also not a perfect square. So cutting the middle number in half is the first thing you do, and I love that you said that because that's what it looks like we did on this one. We took the middle number and we cut it in half. Cutting it in half is part of it. What's the next step? What number would make this a perfect square? Can you tell by looking at it what number would make it a perfect square?
No.
The thing that would make it a perfect square is 4. Plus 4 makes it a perfect square. So we take the middle number and divide by 2, and then square it. Let's see if that worked on the last one. If I took the middle number, which was 2, and I divided by 2, that would give me 1, and 1 squared is 1. You take the middle number and divide by 2, the coefficient of the single variable, the variable is not squared, divide by 2, and square it, plus 4. Now if I add plus 4 over here, got to add plus 4 over here. Now I know, because I did the problem this way, that b squared plus 4b plus 4 is a perfect square. I know for a fact it's a perfect square. I forced it to be a perfect square. So what is the perfect square? b plus 2. 2 times 2 is 4. 2 plus 2 is 4. So the number's 2 equals 7. All right? Now we square root it. Great. So I've got b plus 2 squared, square rooted, and I've got 7 square rooted. Good. Actually square root both sides, and I get b plus 2 equals the square root of 7 Plus or minus the square root of 7. Good.
minus 2.
Minus 2. Great.
-2 plus or minus 7.
There we go. And that is 2 answers. One of my answers is -2 plus root 7, and the other answer is -2 minus root 7. That is 2 different answers, even though we're only writing one thing. Okay? Let me show you a weird one. What are you laughing about? You thought that one was weird enough? That's handy. I've already got 3 things over there. Is that a perfect square? It is not. So, what should I do?
You're going to multiply the whole problem?
I should?
This is
Multiply by what?
3.
That seems like it'd be way worse. P squared minus 3p plus 1 is not a perfect square. It also looks different from the last 2 problems we did. In what way does it look different from the last 2?
0.
Yeah, it equals 0. Also, it's got 3 things on the left side. And the last 2 problems just had variable squared and variable. They didn't have this constant. So I don't like this. I'm going to make it look like the other ones. I don't like this weirdness here. I'm just going to make it look like the other ones. I feel better already. Now what? Because what do I have to do?
Divide 3 by 2. Square it.
Very good. Middle number is 3. Really, it's -3. So -3 divided by 2 is -3/2. So middle number divided by 3 squared. What's -3/2 squared? 9/4. Good. So 9/4 is the thing that gets added to both sides. It's a fraction. Oh no! This is literally the worst thing that has ever happened. Now I know that the left side is a perfect square because I made it that way. What are 2 numbers that will multiply for 9/4 but add for -3? Now that's not an easy thing to think about. It's not an easy thing to do in your head, but I got good news. It's this number. It's -3/2. As a matter of fact, it's always the middle number divided by 2. If you go back to our previous problems, what was the middle number divided by 2? What was 4 divided by 2? 2. And that's what ended up in the parentheses. What was 2 divided by 2? 1. And that's what ended up in the parentheses. What's -3 divided by 2? -3/2. And that's what ends up in the parentheses. It's always the thing that you're squaring that ends up in the parentheses. That's handy. As a matter of fact, turns out the hardest part of this problem is doing -1 plus 9/4. Negative, or sorry, 9/4 is 2 1/4. So what's -1 plus 2 1/4? Yeah, 1 1/4 or 5/4. Yeah, who would have guessed the hardest part of completing the square was going to be the fractions, adding fractions. Cool. Now what? Now we're going to square root both sides. Left side's easy. Right?
2 minus 3/2.
There we go. Equals
Square root of 5/4.
And the square root of 5/4 is the square root of 5 over the square root of 4. And that's important because what's the square root of 4? So this is going to be the square root of 5 halves. It's not really a big deal if you do halves or not. I just like it because now we've got a common denominator. That seems like it's going to be handy. And you're right, it's plus or minus. Good. Add 3 halves to both sides. So we get P equals, I can't combine those because one's got a square root and one doesn't. So it's going to be 3 halves plus or minus the square root of 5 halves. This answer is totally fine. I like that answer a bunch. They do have a common denominator though, so I could add them together. If I did, I would get this. Both of these answers are fine. I think the bottom answer is more likely to impress the ladies at the math party, and the top answer is more likely to impress the person who's doing their homework at 3 o'clock in the morning because it requires the smallest amount of work. So pick your favorite. I like to impress people at the math party, but I understand some of y'all don't get invited to parties, so it's fine if you don't want to do that part. Okay, so every problem that we've done so far has had something in common, which is that the thing that was squared, the x squared, the p squared, the r squared, whatever, did not have a coefficient. In other words, this problem was just p squared. It wasn't 3p squared. So what do you do if it's 3p squared? Skip it. Look at the paper of the person next to you. See if you can get someone who's really good at quadratics to do you a favor. No. You pull out your notes and you say, no thank you, nefarious means of getting my math done. I'm going to do it myself. So the thing that was different last time is still in place here. We've got 3 things over on the left side. And I'm kind of used to just having x squared and x with the number over on the right side. So I'm going to do that first. I'm going to fix this is the exact same thing we had in the last problem. The exact same issue, I guess, in the last problem. So I'm just going to fix that where I got x squared and x. Okay? Easy? Yeah? Okay. Now I want to take care of the new weird thing, which is the 2 in front of the x squared. And the way I'm going to take care of that is dividing everything by 2. If I divide this by 2, problem solved. 2x squared divided by 2 is x squared. That seems good. If I divide this by 2, though, I got to divide everything by 2. Dividing the minus 8x by 2 doesn't hurt my feelings that much. Dividing the negative 3 by 2 hurts my feelings a little bit, but I'll get over it. I'm going to leave my space right here for whatever I'm going to add to complete the square, and then we'll have negative 3 halves on the other side. It's a fraction, but it's all right. Fractions never hurt anybody, as far as I know. All right? Good. We got to figure out what the thing is to complete the square. So we'll take the middle number, which was negative 4, and divide it by 2 and square it. So what's negative 4 divided by 2? Why do you hurt me? Negative 2. And negative 2 squared is?
4.
Just 4. Negative times negative is positive. So positive 4 on both sides. Okay, so I know this is a perfect square. I made it that way. What is the perfect square going to be? X
Minus 2.
minus 2. Yeah, negative 4 divided by 2 is negative 2. And what's negative 3/2 plus 4, my little fraction experts? 4 is 8/2. So what's negative 3/2 plus 8/2? 5/2. Not yet, because I haven't square rooted yet. But hey, speaking of which, what should I do next? I should probably square root both sides. That seems like a good plan. So square root this side, square root that side. X minus 2 squared square rooted is x minus 2. Great. And the square root of 5/2, Lord have mercy, I'm just leaving that as the square root of 5/2. There we go.
Plus 2.
Good. Plus 2 on both sides. So 2 plus or minus the square root of 5/2. This answer's okay. This is not like my favorite answer of all time. What's going to be my complaint with this answer? I have a big problem with that.
Yeah,
That is the square root of 5 over the square root of 2. We don't write answers with square roots in the denominator. We need to rationalize that denominator. So let's come do that over here. The square root of 5 over the square root of 2 is what that ends up being. How do you rationalize it?
I got kicked out on that part.
I can't have a square root in the denominator, so I need to multiply the denominator by something that's going to get rid of the square root. Yeah, let's multiply by square root of 2. And if I multiply by square root of 2 on the bottom, got to multiply by square root of 2 on the top. It's like I'm multiplying by 1. Is this coming back to you? So square root of 10 and root 2 times root 2 is root 4, which is 2. And that's how I'm going to write this answer. I'm going to write it as x equals 2 plus or minus the square root of 10 over 2. Now, if you really wanted to go nuts, I can make these have a common denominator. 2 is 4 over 2. And you could write your answer as 2 plus or minus the square root of 10. Oh, sorry, 4 plus or minus the square root of 10 over 2. This is the answer that's really fast. This is the answer that's going to make people go, ooh la la, that person knows math, I declare. And I think we all know which one we want.
Therapy.
Therapy. You laugh now. Someday you're going to be swiping through your... If you're not already in therapy right now, that's been just a grave misstep in your life. But someday you're going to be swiping through some online dating profiles and you'll be like, this person is perfect for me, but they say they want somebody who can write a quadratic equation as a single fraction instead of the sum of two fractions. I should have paid attention to Taylor. Now my soulmate is going to go with someone else. It's going to be a sad day for you. Makes you feel any better, it's going to be a sad day for me too. I'm going to think, you know what? I should have tried harder to get them to do that. This is, in a way, it's my fault that this true love is not going to happen. I'm sure it won't be the first time a math teacher's name has come up in therapy.
So, subtract 8.
Good. Subtract 8. So 3x squared minus 9x equals negative 8. I think we need to divide by 3 because it starts with a 3x squared, and that's not really going to work for me. I do have to divide everything by 3, which means I'm going to have an 8/3 over there, but it's okay. Don't freak out.
Negative 8/3.
Okay, it's a negative fraction. It's not ideal, but we'll make it work. I left a little space because our next step is to add the thing. What's the thing? Negative 3 divided by 2 squared. Good, 9/4. So 9/4 is what's going to get added to both sides. So I know that the left side's a perfect square. X
Minus 3 halves.
Good. Negative 8/3 plus 9/4 is a little unpleasant. That one's not quite as easy to just look at and get the answer. So let's come over here in the corner and do negative 8/3 plus 9/4. I'm leaving a little space here for what we're going to multiply by. What will the common denominator be here?
12.
12. So this is 4/4. This is 3/3. So that's going to give me negative 32/12 plus 27/12. Good. Negative 5/12. Okay. There we go. Great. Say that again. We got to square root both sides. So we're now going to square root our negative fraction. I'm having a great time. How about you guys? When you woke up this morning, did you know that such wonders awaited you? You probably thought, I bet we're going to do something lame and hard in math class. Well, surprise.
We are.
How dare you? Okay. It's the square root of negative 5 over the square root of 12. What's the square root of negative 5? Square root of a negative means we're going to have i's.
Oh, yeah.
5i.
Oh.
That would be the square root of negative 25, would be 5i.
Oh.
Square root of negative 5.
I
There we go.
was right.
You're right. I root 5. And on the bottom, square root of 12 is
2 square root of 3.
2 root 3.
2 root 3.
I'm going to make it worse by adding 3 root 2. Yep. It's going to be very much worse. Wait, no.
Well, we are
Plus
gonna
or minus?
We are going to do that, but first we're going to do the plus or minus. So now we're going to add 3/2 to both sides. And you said we're going to make it worse, but it doesn't make it worse because I can't combine those two things. One of them has an I and a square root, and the other one doesn't. So it'll be 3/2 plus or minus I root 5 over 2 root 3.
That's it.
Nope. Yeah, our answer has a square root in the denominator. So let's take this thing and come over here and rationalize it. I root 5 over 2 root 3. What do we have to multiply by to make that go away?
3.
Square root 3. So on the top, it'd be I root 15. And on the bottom, 2 root 9.
But that's just
right? So 2 times 3, 6. So my answer is 3/2 plus I root 15 over 6.
So is it plus or is it plus or minus?
Oh, you're right. Plus minus. And if you got a common denominator, this would be 9/6. So 9 plus or minus I root 15 over 6.
Oh, we don't have to do that.
You don't have to do that, but why would you not want to? It's awesome.
It's more writing.
Is it more writing or is it less writing? Okay, it's definitely more. Okay, let's talk about money. Let's talk about money. I'm going to pass the collection plate. Just give what you feel led to give based on your grade on the last exam. You know what this formula is? You know what that's a formula for?
Principal, time, and rate.
You're telling me what the variables mean, and you're right. A is amount, P is principal, R is rate, T is time. What's this the formula for?
Interest?
The eighth wonder of the world, a special type of interest, compound interest.
That's not how we figured it.
Compound interest is the good one. Compound interest is how you become wealthy. So, in this compound interest formula, let's talk a little bit about what each one of these letters mean. A is your total amount. P is your principal, meaning the amount that you invested. R is your interest rate. And T is your time, usually in years. As a matter of fact, I can't think of a time when it wouldn't be years. Okay, so let's say I go down to my bank and I say, I have got 5,000 big ones. I put my money into the bank for 2 years. And at the end of 2 years, it's time to get paid. And I withdraw $5,618. Really? I think that's amazing. $600 in 2 years?
It's actually probably less than that because the rates on deposits are low.
I don't think any bank in North America is going to give you an interest rate that high. That's a good interest rate. Right? Right? Is that a good interest rate?
We have to figure out what it is.
What is, yeah, math. What is the interest rate? So what I just told you was 3 of the variables here. P, the principal, is the amount that I had to invest. And A is the amount that I had after it got done doing all its compounding stuff. And then 2 years, of course, was the time that it was in there. And the question is, was that a good rate? I mean, I made $618 for doing nothing. Doing nothing's my favorite way to make money. How good was that rate? Well, let's take our equation and let's just plug in what we know. So instead of A equals, it's 5,618 equals. And instead of P, it's 5,000. 1 plus the rate. And then T, the time is 2. Hey, look, it's even squared. Oh my gosh. What are the odds that while we were doing quadratics, this person would invest their money for 2 years? Crazy. Can I do the square root property right now? No. Why not? Yeah, I got to get rid of that 5,000. How am I going to do that? Subtract? That's 5,000 times 1 plus r squared. Divide by 5,000. Oh, why do you hurt me? I give, and I give, and I give. And what do you give me in return? Subtract 5,000? Now, I have no idea what 5618 divided by 5,000 is. So I'm going to go to my trusty phone. 5618 divided by 5,000. 1.1236 says my calculator. Equals 1 plus r squared. Okay? Now I'm going to square root it. Now you'll notice that I'm not leaving it as a fraction this time. Why not? Well, you should know by now. I have no problem with numbers that are really ugly. I don't care if it's ugly. As a matter of fact, I prefer ugly.
Wow.
People have told my wife that she must also prefer ugly. Why in this problem am I doing decimals all of a sudden? Sort of. I'm not really talking about money, though. I'm not looking for money. What am I looking for? Interest rate. I want that to be a percent, not a fraction. If you ask your bank what's the interest rate and they go, well, it's 27/11ths. Like, what? That doesn't mean anything. I want an actual percentage, so that's why I'm leaving it this way. So the right side is going to be kind of a disaster. I need to square root the right side. My calculator says that the square root is 1.06. And that's 1 plus r. Let's subtract the 1 on both sides. Good plan. That gives me 0.06 equals r. What interest rate did I get? 0.06 is what percentage? What percentage is 0.06? That's 6%. So I had a 6% interest rate. You multiply it by 100 to turn a decimal into a percent. A 6% interest rate. That's not bad. I don't think there's a bank in the world that's going to give you that interest rate. It's not bad. Okay. Does anybody have any questions?
In banking terms, that makes sense to me.
Yeah? Anybody have any questions about completing the square? All right, let's take a little break, and then we'll do quadratic formula.
Maybe they can't figure it out.
You said we're taking a break, right?
I said we're taking a
1, 2,
break.
3, 4, 5, 6, 7, 8. This
We're
is
gonna make a break for it. I don't know. I don't know. What's he trying to do?
I can't figure it out.